Hello, hello, everyone. No one, whoever's in the chat right now, I can't tell. Welcome to Game Dev Live. I'm continuing my series this week. The fan requested topic of how to hatch a baby dragon from an egg. For those of you who don't know what the heck is going on, I'll give you a quick overview of what I've put together so far. So here is our egg. And yeah, you start the game where you essentially are just an egg. You can pivot the camera around. It's fantastic. And then you left click and the egg breaks open and we got our chubby little baby dragon inside. And then the dragon hatches. He can move around and do a bit of a flying jump that looks kind of lame, but we didn't have all the animations required to make a jump look correct. But anyways, and then you'll notice we've got a watermelon there that he just ate. So that's an automatic thing. Once you get within a certain radius of the watermelon, the dragon automatically turns towards it and eats it. Now, you might notice that all of a sudden our dragon is kind of floating off the ground there. So I noticed that at the end of the stream last week, and I didn't have a clue why it was happening. But then as soon as I ended the stream, I thought about why that is actually happening. And the reason being is inside of our baby dragon character, we set up this player look at target. And we've got basically what we're doing is we're getting the location of the camera and the location of the player, and we're lerping that into the look at rotation. And we're plugging this into the world rotation of our player controller and our capsule. So the problem is I just plugged it directly into rotation. So that's actually rotating it X, Y, and Z, which is not what we want to do. Actually, I'm going to undo that. Put a little break in there. What we want to do is split struck pin there. And we only want to take our, let's take this out, break. We're going to break our rotator. And we only want to affect the Z. So that means it's going to face the watermelon by rotating towards it vertically, but not horizontally. So then we probably want to keep our original rotation, which is our player rotation. So that is this node here. I'm going to duplicate that and split struck pin there and feed back our X and Y into that. And that should, theoretically, if I know what I'm doing when it comes to coding, which, you know, that's why I subtitled this, Come Learn With Me. I don't know everything. I'm still learning myself. So it's always, that's what's awesome about game design is it doesn't matter how long you've done it, you're always learning. So that should fix it. So now if we hit play and we hatch out of our egg, we should see that as soon as we face the watermelon there, yeah. Oh, see, I was hoping, I was hoping that was going to fix our problem with the dragon tilting up into the world, and it didn't, and that is weird. So this is another one of the joys of game design. Now, why the hell? Because we're only, oh, wait, no, that's the player rotation. Sorry, I got confused for a second, and I thought I was doing the opposite of what I wanted. So probably back here, trying to think if I need to break our lerps down even more. Get our player rotation. Lerp to B, which is that. Set that as our player controller. Yeah, this should actually be working. Because, now, give me a second. I gotta just double check. So when I spawn my dragon, yeah, he's not doing that floating over the ground thing. But then when we face him towards the watermelon, oh, what the hell, UE 4.26? He's not doing it anymore. So the first time I played it, he was, but now he's not again. So, oh god. See, this version of Unreal is the glitchiest I have ever experienced. For some reason, it seems that when you compile and save a blueprint, hey Spoon, thank you for joining me. Sorry guys, I'm getting distracted. Good to see you, man. Hope you're doing well. Yeah, so for whatever reason, 4.26 seems buggy as hell. Like you'll have to like close down the character blueprint and reopen it to get certain controls working. And clearly that's the same thing. I knew this would fix it. And yet the first time I went through and played it, it didn't. So yeah, fun. Go Epic, introducing new bugs. But so one of the things that I wanted to do is once our dragon is hatched, excuse me. Try and get my webcam aimed a little bit better. Once our dragon is hatched, so one of the things that you'll notice with quadruped creatures, pretty much any character actually, but it's more noticeable with a quadruped, is that their feet don't sync up with the ground. And when you're walking up and down hills, for example, let's see if we can even get up on this surface. There we go. Looks like it's working a little bit. You'll notice that he's floating in the air. And that kind of breaks your immersion. Also, when you're going down a hill, he's still facing, and it causes the character to jump a lot too, automatically go into jumping or falling. But yeah, he doesn't align to the slope, the surface, which also looks really bad. So Epic actually bought a company that was working on an IK plugin. So for those of you that don't know, IK stands for inverse kinematics, and it's a way that you're essentially you're manipulating the entire skeleton of a character. So there's IK, inverse kinematics, and there's forward kinematics. And forward kinematics, you're animating based on rotation. So you'll grab, the shoulder bone and you'll rotate it up this way, and then you'll grab the forearm and you'll rotate it out that way. And that's traditional animation. Whereas IK, essentially you can grab any point on the limb, like the hand, for example, and as you move it around the world, the rest of the skeleton chain will follow suit, and it will adjust itself, adding rotation and, basically rotation on the fly. So the cool thing is, if you can use a blend of the two, you can essentially manipulate the animation dynamically during gameplay. And so by setting up an IK system on this dragon, what we can do is we can actually have his feet find the position of the ground. We can set his pelvis or his root bone to actually adjust to slopes. So it's really cool. But setting up an IK system was previously a bit of a headache. It takes a lot of time. But this Power IK that Epic bought recently is fantastic. It's like a couple of minute setup, and you've got everything solved, all the issues that we're talking about solved. So yeah, if you go onto the Epic Marketplace here, and you do a search for Power IK, you'll see it right here. I've already got it installed to 4.26. So now I'm just going to go in and turn it on. But you'll see here that you get the option to install, to download on your end if you haven't already. It's free. It's now owned by Epic. So probably this is the IK system that they've integrated directly into Unreal 5 with the latest release. They were talking about their new solvers and stuff. And yeah, so once you've got that, you can go into your project settings here. Sorry, not project settings, plugins. So edit plugins, and you can search for Power and turn on Power IK. It's going to ask you to restart. So of course you want to save everything and restart the editor here. And then it will pop back up and we've got the Power IK ready to go. So now what we're going to do, we're going to jump into our character blueprint. So I left everything open from last time, but we've got our Dragon the Soul Eater anim blueprint. So we can go in here and we want to go into the anim graph. So we open up the anim graph, and there's a couple of ways that you can implement Power IK. A lot of the times, if you're doing an IK solution, you'll implement it right here. However, what we're going to be using is we're only going to be using a small portion of Power IK, which is grounding the character. So we don't want to put that here because essentially it's going to be constantly grounding our character, and you don't want that to happen while the character is jumping. Because then as you try and jump, it's going to try and stretch your limbs and keep your legs planted on the ground, and it'll give you some really wacky results. So what we want to do is we want to put it into the idle walk and run state because we want to be able to have it turn off when we go into our jumping, or later if you wanted to implement it going into flying. So we go into the idle walk run here. We just drag this over and we search for Power. You will see we have these new solvers essentially. So we've got Power IK ground, Power IK solver, and Power IK walk. As far as I understand it, walk is for generating procedural animations. So you can actually set it up so that the computer system is making the animations on the fly. I tend not to use that because it doesn't look too convincing yet, but you'll get animations similar to Spore, if any of you guys have played that game. Solver is, it has multiple different uses, and then ground is the one that we're looking for. So we're going to grab Power IK ground. I don't know why I always get an itchy nose when I'm on stream. Apparently I'm allergic to a camera or something. It's fantastic. And then, yeah, so the first thing, it's going to default to the character root being the pelvis, but it really depends on your skeleton mesh. Since we downloaded this skeleton from the marketplace, there's a good chance that they didn't go with a traditional naming convention. So what we want to do is we want to jump into our skeleton, and you'll see here, yeah, it's not actually named pelvis, it's named root underscore pelvis. So to check to make sure that is your root, you can go into the transform mode or translate, and we just want to see if we can actually move our character around. So if you were grabbing the spine, for example, you'll see you can't translate properly because half the body gets left behind. So that's clearly not going to work. So yeah, we want the root pelvis node. We're going to right click and choose copy selected bone names. And then we're going to go back in here and we're just going to double click and paste that in. So now we've got the proper name for our root bone. Then we're going to simply drag this out and plug it in there, and you get an automatic conversion of local to component. And then we'll drag this out, plug it in there, and we get a component to local. I've always been curious why they bother converting it. Like, you think these would just be coded to work with local, but I don't know. Maybe it's something to do with the animation system. It can't. Anyways, so we're going to highlight our PowerIK ground node, and we're going to go into the feet array, and we're going to add in 4 different elements. And then we're going to go back to our skeletal mesh, and we can click or get in the lower arm there. But that should get our feet. Yeah, so he's calling this hand right, which is fine. Again, we're going to right click, copy selected bone name, go back to our anim blueprint, and in here, expand this out, bone name, hand right. I believe we can leave all of the default settings, go back in here, find our hand left, copy selected bone name. So you might be thinking to yourself right now that this is a bit of a tedious setup. Yeah, maybe for 30 seconds, but it's so quick. We're actually almost done everything we need to do. So then we're going to go back and reverse leg right and find the foot. He called it feet. Interesting. I would imagine that's foot because it's singular, not plural, but to each their own naming conventions. Sorry, I'm just going to make sure, yeah, I did do that one correctly. Feet right. And then, whoops, switch over to this side. And grab our feet left. Copy. Yeah, right. 0 to 3 instead of 1 to 4. All right, so the next thing you want to do is this feet delta smooth speed. Probably up that to 300. I don't know why it defaults to 200 in the PowerIK setup tutorial. They increase it to 300. Just essentially what that's doing is it's counteracting sometimes when you jump, your character hits the ground and their feet will penetrate through the ground before then finding the surface. So that's just boosting the speed at how quickly it finds that surface and realigns it. Hey, no worries, Spoon. Thanks for joining. It's just nice to have a body sitting in the stream instead of streaming to no one. Hopefully in the future that'll change, but you never know. So yeah, so we've got the feet delta smooth speed increased to 300. Then what we're going to do is we're going to need to change our collision. So right now, if we compile and save, what we'll find is that we've essentially just given our dragon a way to fly, but not properly. Because what's going to happen is it's going to do this solver trace, and our dragon is essentially tracing against its capsule collision and then standing on the surface of that, which is not going to work for us, obviously. So what you want to do is we need to set up a custom collision channel. So we're going to go into Edit, Project Settings, and we'll scroll down here until we find Collision, and then Trace Channels here. So essentially what a trace channel is, hey, How's it going, Xenexalon? I can't remember how to pronounce your name. Jeez. Anyways, trying not to use real names. These are friends of mine that I game with, and yeah, thank you for joining the stream. No worries. Yeah, it has been a while. Good to see you though. Thanks for joining. All right. So, trace channels here. Okay, so essentially, a trace channel is anytime in a game where you're trying to get information about the world or, yeah, an object. Typically, it's done through traces. You may have heard it called ray tracing. You know, it's shooting out a ray or a laser, essentially, and hitting something and then getting information from that hit result. So by default, the Power IK ground node, it's set to world static. So essentially, that's going to include your player, which is weird because your player is actually world dynamic. But hey, who knows? Oh, sorry, my dog's trying to break in. Gigs, how you doing? Come on, let's go. Don't just kick the door and stand there. Come in. My dog is demanding to be let into the room. He likes to sit beside me. Hi, bud. Yeah, good boy. Have you guys seen my dog? I introduced him last stream, or rather, he introduced himself, but he likes to hang out with Daddy. Anyways. Okay, lie down. Good boy. All the way. Down, down, down. Down, down, down. Yeah, yeah, yeah. Okay, bye. Anyways, so yeah, essentially it's detecting the player's capsule collision. In this case, the player is our baby dragon character. So this sphere here, it's tracing against that sphere and then trying to relocate our character mesh to that surface. And we don't want it to trace against that surface. We only want to trace it against the trace channel. So we can choose to pick which objects it will actually collide with. And okay, so back in our project settings here, we're going to create a new trace channel. And we're going to call this IK trace. And our default response will be block. That's fine. Actually, no, I'm going to say our default response will be ignore, accept. And then we're going to go into the preset here. No, actually, I did do that wrong. Our default response should be block. And then in the presets here, what we're going to do is we're going to tell it to block, ignore the pawn. So we're going to open up pawn, and you'll see our new IK trace here. And we're going to click on ignore. So this is specifying this custom trace channel's response to the pawn actors, or any object that's got pawn as its collision type. So we're going to tell it to ignore and accept, and then character mesh, we also want to do ignore and accept. And essentially what that will do is now when we go back into the game, you'll see that we're no longer floating on top of our collision sphere because it's ignoring those objects, but it will trace against everything else. And of course it doesn't work. Getting tired of this. Now I'm starting to think that that is just a 4.26 glitch. So I'm going to ignore it and hit play again and see if it happens twice. And if it happens this time, then I'm going to take a quick look to see what I missed. Yeah, so it is still happening. So I might have missed something in the Power IK setup. So give me a moment here. So we're going to go into the library. We're going to scroll down and search for Power IK. And I'm going to launch the documentation probably. And I'm going to look here for the ground node. Figure out setting up a custom collision trace. So IK trace, default response to block, open the preset, collisions, double click pawn and set to ignore, character mesh set to ignore, locate and select the power IK. Oh yeah, all right. So I did everything correctly. The part that I forgot to do was simply to assign that collision channel to our character now, or to our power IK ground. So now collision channel is world static. We need to set that to IK trace. Compile and save. So part of it is 4.26 glitching, and part of it is me having a bad memory. Memory of a 41-year-old guy. That's the problem. So yeah, now you'll see that our dragon is correctly adhering to the ground. He's no longer, I don't know if you guys noticed before, but his back legs were floating slightly. So now he's a lot more grounded. If we go over here and we take a look at how he's reacting on a slope, you'll see that as we go on the slope, he's trying to adhere to that slope a lot better. One thing I want to do actually here in our dragon character, I'm going to get our camera boom, and I got to set the target offset to maybe 150. Compile and save that. Hit play again. And this is just going to raise our camera up a little bit. Maybe too much. Let's go with 50. Compile and save. It just makes it a little bit easier. And actually, I think I'm going to drop it back further too. So on the camera boom, target arm length, I'm going to set that to 450. A little bit further away. There we go. So now we can get a better look of how his feet are responding. And you notice it looks a little bit glitchy as he's walking. Essentially what's happening is it's playing the animation. His back right leg looks a little stiff. Actually, both of his back legs look a little bit stiff. So that is one of the downsides to IK, is it's constantly trying to calculate against the world and then reposition the leg. So it is adjusting your animations on the fly. So it has the downside of looking a little stiff sometimes. But yeah, you can see that our essentially our dragon is trying to adhere to that slope. Now, there are a couple extra settings we can adjust to make this even better, which is we can go into our Power IK ground node again, and we can scroll down, and we're finished with the ground collision. Now we can open up ground slope, and we've got a couple of options here that we can turn on. Oh, probably I shouldn't have adjusted my camera during stream. There we go. So yeah, essentially, first thing you see is we've got Orient to ground. So if true, the entire skeleton is rotated to align to the ground, useful for quadrupeds. Yes, please. We're going to turn that on. Compile and save. And the first thing you will notice is it's going to look a lot better when it comes to walking up that hill there. So if we go back to our hill here, rather than just trying to reposition the feet, it's actually going to rotate the whole dragon's body. So you'll see that he's not penetrating through the ground as much. His feet look like they're, his whole body looks like it's, you know, aligning to the surface. But his feet are penetrating a bit still. So we can fix that up. The next thing we can do is we can, well, let's see, scale stride. Doesn't matter. Lean. So, if true, character root bone is rotated in the opposite direction of the ground normal. Yeah, we definitely don't want that. Bipeds would do that. As you're walking downhill, you're going to lean back a little bit. You definitely don't want leaning for a quadruped. Move root. So essentially, if true, the character's root bone position is gradually pushed vertically and horizontally to align the slope. We could turn that on and see what it looks like. Let's try it. And so the reason why I'm not just checking all these off and then going to see what the results are is because you don't know what checkbox is affecting what. So essentially you want to test them out one at a time. Probably I should take our egg. Whoops, we got a rock behind us. Probably I should take our egg and grab it along the X and Y. Probably I should have held shift before I moved it. So if you hold shift down while moving objects, your camera will slide with it. I'm trying to get it closer to this mountain that we keep climbing up so we don't have to take so long during testing here. Put that back down on the ground. Break out. And probably I want to remove the 3-second delay there as well. So yeah, I can't personally see a whole lot of difference that checkbox just did, other than the fact that maybe it looks like it's readjusting a little bit slower. It looks like it's like gradually moving as opposed to immediately moving. So I'm going to turn that move root off. Rotate foot to ground. So that'll actually take the ankle bones and rotate them. Yeah, it could be helpful, but it looks like our dragon looks pretty good. And then offset feet position. This is definitely something that we want to, oh shit. Edit, undo. I did not want to adjust the downhill slope. Yeah, it looks like that didn't undo correctly. I was trying to grab this slider and push it over, not that one. Anyways, so yeah, offset feet positions. So essentially, you notice that our feet were sinking into the ground there for a bit. This will help mitigate that. So now we should see that our feet are actually adhering to the ground a little bit better. Essentially, it's just pushing them up in the air an extra 4 units. So they're not going to collide with the slope as much. So that can help. But yeah, there we have it. So now our dragon actually, well, that slope's a little too high, but our dragon is actually adhering to the surfaces a heck of a lot more. We can make some adjustments too. The offset for the feet is going to be something that we need to tweak, because at some point we're going to actually be at some point very soon we're going to actually be causing our dragon to grow, and so those numbers probably we need to find like the happy medium, because as the dragon gets larger, you're going to need larger numbers to offset the feet. And since our dragon's fairly small right now, the numbers are going to need to be fairly small. So anyways, so now we can eat our watermelon and our feet stay up planted on the ground. So that's fantastic. All right. So moving on to finish up our tutorial. So the last thing we had done is we created this dragon food. And so essentially on overlapping this spherical trigger, we're checking to see if the overlapped object was a character. If it is a character. Now this is a catch-all, the way I've coded this. it will actually allow any character to eat the watermelon if you're only checking against get player character. However, we're also then immediately casting to our baby dragon specifically. So this whole part there is pointless. If we're going to cast to our baby dragon right afterwards, then we can just get our other actor and plug that directly into the object there. And we don't need to do an equals. But most of the time, it's just habit for me to drag out the other actor and go equals character. Because that way it's not programmed for one character specifically. If you have multiple characters in your project, that's a way that you can avoid it. Also, something else to keep in mind, if you're dragging out and choosing equals, and then we're saying get player character, this is essentially grabbing only the player character at index 0, which means if you had a multiplayer game, or as I found out recently with another project, if you were respawning characters or essentially spawning a new character and possessing it for your respawn system, you actually come in as a new player index. So I was working on a project where when the player dies, their body stays in the world, and then it spawns a new version of themselves. It's like cloning. And that character that you were previously controlling still exists in the world, and it's still assigned to player index 0. So in order to avoid this, because this again is also a bit of a hard coding, it's similar to like magic numbers. You never want something that's just undefined, and this here is kind of undefined, or rather it's too defined. We're always saying get the character at index 0. If you actually use get owner, and then from get owner we were to cast to character, what essentially that's going to do is every time we create a player character, they're all going to inherit from the parent class of character. So our baby dragon character, if we look at that, the parent class is character. So if you program this way, where the hell were we doing that? So if you program it this way, if you get the owner, so it's going to say get the owning actor. So whatever overlapped this sphere, get the owner. In this case, the owner would be our baby dragon, and see if it is a character. And as long as it's a character, then you can allow that trigger to be true. But in this case, since we're calling specific code, like look at target off of our character, then in this case, what we would have wanted to do if you had multiple characters in your project, see you, Zenexalon. Thanks for joining. Have fun. Yeah, if you, sorry, bleh. If you wanted to have multiple characters in your project, you'd create essentially your own parent class, and then you would implement your look at code, etc. So if we wanted to do multiple dragons instead of just our little chubby dragon, if we wanted to have a couple of different dragon types, then you would probably create baby dragon character as like your master character class, and then you would create sub characters or sub blueprints, child blueprints based on your master blueprint, and that way it just essentially it's a cleaner and better way to program. You're not limiting to one specific character, and then you have to go back and fix your code at a later date. Anyways, I digress a little bit here, so getting back to it. So essentially what we're doing is when the character walks into the trigger of our food, we're telling them to look at it, and then we are turning on eating And that's triggering us to go in to the eating state on our anim graph. So if we go to our state machine, it goes into eating, and then he comes back out after he's done. So when he's eating, plays the biting animation, and when he's finished eating, he stops playing that animation. So then we're turning off the visibility of the food mesh to make it essentially look like he's eaten it. We're delaying a little bit, 0.2 seconds later. So here we turn on eating, 0.7 seconds later, we disappear the food mesh, and then 0.2 seconds after that, because our animation is approximately 0.9 seconds, we turn off eating, and that just prevents the character from getting stuck in an eating animation loop. And then we're just destroying this actor, which is the food item. So that's fine, but we want our dragon to grow. So probably before destroying the actor, probably we want to run some code to cause our dragon character to scale up in size. So I think the simplest way to handle this is actually just going to be taking our capsule collision from our character and scaling it up. And we want to be able to do that smoothly. So we want to create a system similar to our player look at, where we're using a timeline to drive the smooth transition of scaling. So I'm going to take our disable enable input, and I'm going to drag that up here because it's closer to our controls. In fact, we don't need reset VR, so let's just drag that right up in here. It's kind of like a control. It's not an input, but it is input related. So this is our player look at target. So now we're going to create another custom event. I'm going to call this player row. And so similar thing. So the first thing we want to do is we want to get our capsule component. And we want to create a timeline here, actually. So timeline, add timeline. And we're going to call this timeline underscore, let's just call it dragon. Oops, typos. Dragon grow. And the reason I did that now is because before we do anything with the timeline, we want to initialize our code here. So we don't need to check if a look at target or anything like that is valid, because what we're doing is we're just increasing the size of our capsule component, so you don't need a validation check in there. We're always going to be able to get our capsule component. We do want to set the default scale of it, but also over here where we disable the controls and we set the play rate. So I'm going to highlight that and copy it. And I could come down here, paste that in, because why bother typing it out again? But this time, instead of look at timeline player look at, we're going to get from our components timeline dragon grow. And maybe since I'm calling the other one player look at, I'm going to call this player grow. If we were doing a master class, again, this is where like maybe our character isn't specifically a dragon at all times. Maybe you get to switch between being a human who rides the dragon, and therefore, you know, your naming conventions are kind of important. You might not think they are, but it's good for later purposes. If you come back to a project or a portion of your project 3 months later, and you didn't choose your names carefully, then it can get really confusing trying to sort through your own code and figure out what the hell you're calling where. So that's where naming conventions are really important. But also, if you ever bring anybody else onto the project and they want to, you know, get an idea of what's going on. So it's like code commenting. You just want to make sure that you're naming things properly from what's actually happening. And we're going to actually just plug that into play. We don't need play from start. And so instead of our look at speed, we're going to right click and promote this to variable, and call this grow speed. And so essentially, if you guys missed it last week, what this does here is on a timeline, if we set the timeline's length to 1 second long, and we're going to be creating a float track, but this works with any kind of track, so vectors, events, or what is that, color? It is a color track. Anyways, float is mostly what I use. So I'm going to name this alpha because that's how we're controlling a blend. And we're going to put down 2 points by shift left clicking the timeline is how you put a point in. So we're going to set this one to 0, value of 0, this one to 1, value of 1. And essentially what that's telling the timeline to do, and we're going to click on this one and choose auto. That just smooths the curve. So instead of a linear curve where it's instantly applying the same value, think of it as like a door rotating, right? When you close the door, the initial push might be slower or faster, the initial force applied. So it'll speed up essentially or slow down at the end. That's what auto setting the first vertice to auto is doing, is it's smoothing that curve. Because if it's linear, it means it's going to rotate at exactly that same speed throughout the entire animation, which looks odd. Great for mechanical things like robot movements and stuff, because they would be consistent because they're being turned by servos and what have you. But for an animation, to make it look more natural, you want to have a smooth curve. So that's essentially what this is doing here. Yeah, so, and then in our timeline, so at 0 seconds into our timeline, the value of our output essentially is going to be 0. And then at 1 second, the value is going to be 1. So essentially that's going from 0 to 100, or 0 to 1 is how Epic codes everything. So you're using fractions or, yeah. Anyways, so essentially this is during the timeline, during this 1 second. So at half a second, you'll see if we hover over the value, at half a second, the value is 0.5 or 50%. So it's using a floating point value, which is a decimal. So basically, we're adjusting the value over time. So over 1 second, it's essentially switching from A to B. But instead of just doing a hard switch, we're doing a smooth switch. So halfway through, you're getting both A and B in equal amounts. And that's what allows you to have a smooth transition. I realized I didn't explain that last time. I like to try and go through and explain what the nodes are doing rather than just telling you what to do, so you can understand how this works. It just makes learning a little bit easier. I notice a lot of tutorials, even the professional ones that I myself have paid for, they'll tell you what to do, but they don't tell you what you're actually doing. So I'm trying to do that here. So essentially, what we're going to be doing is we're going to be lerping a value. So we're going to get the size of our capsule collision. So that's what we've done here. And we're going to drag out, and we're going to go get scale, no, transform. Scale? Scale? Can we get scale? Get scale. World. Yeah, we can. We can get the world scale of our capsule component. Sorry, it tried to throw in another capsule component there. So we're going to get the world scale. So whatever the current scale value is, and we're just going to set that. We're going to promote it to a variable and call this capsule scale. I was checking to see if I spelled capsule correctly. So essentially, what we're doing here is we're saying, hey game, read whatever value the scale is, which it defaults to 1. Read whatever that is, and then save that. We're storing it as a variable. The reason we're doing that is because when we blend to a new scale, so when we try and scale this up, in order for our timeline to actually work, so let's say we're changing the scale from 1 to 2. So if we do that over 1 second, the timeline node, this update, actually runs every fraction of a second in between. So for an entire 1 second, it's essentially becoming a tick event. So every frame, it's updating the information. So if we don't store the default value of our capsule component, if we just get the capsule component scale without storing it, essentially what's going to happen is over here, we're going to update the scale. So we're going to take our capsule component again, duplicate that with Control W, and I'm going to put it up top there. And we're going to choose here is set world scale 3D. And we're going to run this command off of our update. So if we don't hard lock this in as a scale of 1, essentially what this timeline is doing then is it's ticking. So every frame, it's getting the scale of the capsule component, and then it's setting a new scale. So as we scale it up, the starting value will change. So instead of blending from 1 to 2, you're actually going to be blending from 1 and then 1.1 and 1.2 and 1.3 and 1. So that value, that initial value, will be changing as it scales up. And what that'll do is it'll still work. You'll still get a transition from 1 to 2, but it's not going to be over 1 second. It's going to mess with your timeline. So even though our timeline is telling this scale value to happen over 1 second, because we're not hard locking in our initial value, or if you weren't hard locking in your initial value, what would happen is as the timeline plays, that initial value is going to be changing. And so you're going to be getting incorrect values or results from your timeline at that position in time. So essentially what it does is it compresses our timeline and ends up speeding up the rate at which your character will grow. And the problem with that is then you can't control how quickly you want it to be. So the whole benefit of us creating our timeline here, and I actually just realized I didn't fully finish explaining that. So we created our timeline as a length of 1 second, and we're blending from nothing to everything. So we're going from 0 to 100% over a 1 second time period. What we're doing here with the setting the play rate is setting the play rate is essentially a way that you can adjust the speed at which this timeline plays back. So setting the play rate of an animation, for example, if we go to the attack mouth, right, this animation is 30 frames. So you know, depending, it essentially, I was going to say that it's going to take 1 second, but it depends on the rate at which the game is operating. It's not the same as a 60 FPS game, doesn't change the speed of your animations. But anyways, so if you look here, this animation is essentially 1 second long. So if we were to change the rate scale here of our animation to 2, we didn't change the frames. It's still 30 frames. And we didn't change the time. It's still 1 second, but we're playing it back twice as fast. So now it's going to be a half-second animation. So you notice that this animation itself is a lot faster. So if we set it to 0.1, you're going into slow motion. If you set it to 1, you're going back to real time, essentially. So that's an easy visual way to show you guys what a rate scale does. And so the same thing applies to our timeline. sorry, where was that? So our timeline here, essentially we're getting a reference to our timeline. So once you create a timeline in your event graph, it'll show up in your components as well, so that you can actually, act on it or make changes to it. So we're essentially getting a reference to our timeline before we actually play it, and then we're setting its play rate to a new value. So by default, the play rate of a timeline is 1, and you can hard code the new time here, I believe. Maybe. No, maybe this one here, the float here, is probably for where in the timeline it's starting from. Anyways, so the play rate defaults of a timeline, it defaults to 1, which is the actual rate of the timeline. So whatever you specify, your length. But by setting the length to 1 second, we're actually allowing to change this dynamically on the fly. So when you create a timeline here, you can't change the length unless you physically come into your code and adjust this number. So if we wanted it to be 2 seconds now instead of 1 second, if I switch this value to 2, that's actually increasing the length of our timeline. So if I scale these now, oh no, of course it's scaling based on the keyframes. But you'll see that our duration of our timeline is 2, but it didn't change the position of our keyframes. So this point is still, it's still getting to 100% after 1 second. It's not after 2 seconds. So with timelines, you have to, they're hard coded to play at a specific length. So just increasing the length there won't change the results. It'll just append an extra second of time onto the duration. So when you look at the timeline here, if we close this out, you see when it's finished, any extra seconds you add on to this, it'll take that long for the timeline to complete, even though the last keyframe is on 1 second. If the timeline's set to 5 seconds, it'll take 5 seconds before this fires. So to be able to dynamically adjust the speed of a timeline, we use this little bit of code here. So we set the play rate, we take this value of the play rate and we divide it by another value. So in this case, we're taking the play rate, we're dropping it, and actually because I did that last week, and you might just be tuning in now, we take this new rate out, we hit the / key to get a divide, and we do a float divided by float. And we're essentially taking 1, which is the value of our timeline, 1 second, and we're dividing it by a variable that we can customize. So in this case, I simply promoted that value of 1 to grow speed. So by default, it's 1, which means we're taking 1 divided by 1, which gives us 1. We're not changing the rate of the timeline with this code. But if I take the grow speed, sorry, and I compile that, and I set the grow speed now to 2, essentially it's going to take 1 divided by 2, which is going to give you 0.5, and it's actually going to speed up the rate of our timeline. Now, if we did the same thing with 10 seconds, the 1 divided by 10 is going to give us 0.1. And our play rate, that is essentially setting the play rate of our timeline. So it's going to happen in essentially 10 times faster. It's going to happen at 1/10 the speed. So yeah, so that's how we can dynamically control the play rate of our timeline. So essentially, if you code your timelines this way, you always set them up to happen over a 1 second duration, and then you set your new play rate before playing the timeline to 1 divided by whatever value you want. Then over here, when we go into our growth speed and we give it a tooltip, so we can call this time in seconds it takes for the player to grow to the new scale. So that's essentially what we're doing, is we're setting this as seconds. So if we set it to 10, it's going to take 10 seconds for the blend to happen. If we set it to 2, it's going to take 2 seconds. If we set it to 0.5, it's going to take half a second. So yeah, because it's adjusting our play rate of the timeline dynamically. So I'm going to leave that at 1 for now. We can play around with the value later. We're going to plug that into there. So essentially, on player grow, we're getting the scale of our capsule component. We're setting that to a static value. Then we are disabling the player controls. We coded that last week. We're just using a disable input and an enable input command. And the cool thing with disable input is it actually disables your mouse movement as well. So it's a great way to handle this. So we disable the input simply because we probably don't want the character running around while the growing event happens. Also, we could play some particle effects or something like that to, make it look fancy. I'm not going to bother getting into that. So we're disabling the player controls. We're setting the new play rate of our timeline, and then we're playing our timeline. So what are we doing here? So what we want to do now is we want to get our capsule scale value, and we want to lerp this. So a lerp is essentially, it's called linear interpolation. Essentially what that means is we're doing a blend. We're switching from one value to another value. And so our new value, what we want to do, probably we're going to duplicate our capsule scale. Actually, probably we want to have the character scale up to a new specified amount. So we're going to actually, we can't have this hard coded. So I was originally thinking we're going to duplicate our capsule scale, but we can't do that because if we want them to grow multiple times, it can't be a hard coded value. So what we want to do is we actually want to get our capsule scale, and then we want to multiply it by a variable. In this case, we're going to multiply it by, so let's see here, vector times a float. So our floating variable is how much he's going to grow every time this event happens. So probably we don't want him growing to double the size every time. So probably I'm going to say, well, you know what? For now, I'm going to set this to 2. The reason being is we want to start with an extreme value just so we can test to see that everything's working. So we're going to get whatever our capsule scale is. So when we start out, the scale of our capsule component is 1. But then we're going to actually increase that. So the first time this plays is going to take 1 times 2, and it's going to give us a value of 2. So we're going to grow to double the size. But by coding it this way, we're essentially allowing it, we're allowing for the fact that we don't know how many times this code has run, and we're going to be able to dynamically calculate out what the new size is. Because after the first time this code runs, this capsule scale value, the next time we issue the player grow command, is actually going to pull out a 2 here instead of a 1. So instead of being 1, 1, 1, after we've already run it once and increased the size, this value will now be set as 2. And then you're going to get 2 times 2, which will be 4. So you're going to get double, you're going to double in size every time we eat a watermelon, essentially. So we're going to get whatever the capsule scale is, and we're going to multiply that by our growth rate. So I'm going to right click and promote this to a variable. I don't know why I keep calling it a variable. Growth rate. So we're getting our capsule scale. We're multiplying it by our growth rate. our growth rate variable is going to be 2 because we typed the value first. So that's a tip. When creating variables, I see a lot of the time people create it here, which is fine. It's just, it takes a little bit more time because when you create a variable here, let's say we create a variable of float, we can't set the default value. We have to compile before we can then set the default value. Whereas if you simply take the amount, you plug it in here to 2, and then, or let's do 5 just for example's sake, and we promote that to a variable. Let's just leave it as alpha. Now when I compile, you'll see that the default value has already been set to 5. So when you type in the value first and then promote that to a variable, it actually defines it at the same time as creating it. So it saves you a step. Anyways, it doesn't matter what we type in here because as soon as I plug that in, it'll be overridden. So our growth rate default value is 2. And then for our alpha, we want to plug that into here. So essentially what this code is saying is we're getting whatever, so a lerp starts on A and ends up on B. So when you hover over here, so it says linearly interpolates between A and B. So again, that linear curve, when I was in our timeline here and we were talking about smoothing this out, a linear curve, oops, sorry, not user. Linear curve is a straight line, so it's completely flat. So it gives you a very exact, consistent scale. By switching it to auto, it smooths that scale out. So a lerp is always going to happen just at a flat rate, but you can adjust it with your alpha there. So by changing the curve of our timeline, we're essentially making this nonlinear. But anyways, so it's essentially just going to flip between 2 different values. So it's going to take whatever our capsule scale is, and it's going to convert that number into our capsule scale multiplied by our growth rate. And it's going to do that based on the alpha of our timeline. So essentially, at 0 seconds, the capsule scale will be 1. And then at 0.5 seconds, that scale will be half of our growth rate. So half of 1 times 2. And then by the time it gets to the end of the timeline, it'll be at the full amount. So 1 times 1 times 2. So essentially, yeah, essentially that's what that's doing here. And then we're going to set that value to our new scale of our capsule component. And that will allow us to cause our character to grow. So something else to keep in mind. And I'll show you this. We'll demonstrate it in the video. But as I was saying earlier, like for our no, it was in there. So inside of our Power IK, when we were setting up in the ground slope values here, when we were setting up our static foot offset. So when our character is a regular scaled character, 4 units is a decent amount of offset. It's 4 centimeters. But when your character is 300 feet tall, these numbers don't matter as much. Taking a 300-foot tall character whose toe is probably, 5 or 6 feet in height and shifting it up 4 centimeters is nothing. The value becomes inconsequential. And the same thing here with our dragon character is our character movement. So by default, our maximum walking speed here, let's see, where is that character movement? Where's walking? Networking, jumping, falling, walking. So our max walk speed is 600. So a max walk speed of 600 when your character is tiny, he's zipping around like Speedy Gonzales. And a max walk speed of 600 when your character is 300 feet tall, he's moving like a slug. So that is something you would also want to adjust, and we'll get into that. We're also going to want to define how many times this code can run, because essentially you don't want the character to be able to grow indefinitely. You probably want them to reach a maximum size. Or even if you do want to allow them to grow almost indefinitely, you want to be able to know how much to increase that movement speed to match. So let's see. So we've got player grow. So we can drag a box around that and hit C for a comment. And we can type in player grow. That is all of our code for causing our player to increase in scale. So now we can go back into our dragon food, and we can drag off this line underneath here as a reference to our baby dragon character. So we can drag off here and type player grow, plug that in here. So control left click to drag out your pin. And that way you're just to show you guys what the benefit of control left click is. If I just were to drag this in, it immediately deletes the connection. So now I have to drag out a new point there. So if you've already got it connected up, if you just control drag out and plug it in, it just makes it easier. It stays connected to whatever node it was connected to previously. And then I'm going to double click a point in there to just keep that clean. So essentially now what we've done is we're casting to our baby dragon character. We're telling it to look at the target. We're telling it to play our eating animation. And then after he's finished eating, he's actually going to grow in size before the watermelon actor is removed from the world. So let's take a look, see what that looks like. Oh, and we might want to move. Let's just drag our watermelon itself. Bring that over here. I'm going to lift it up in the air and then hit the end key on the keyboard to drop it back down on the ground. And then we're going to drag our rock just so we have a comparison here. So the rock is how we see very easily that our dragon is actually growing in size. So now when we hit play, we break out of our shell here. Oh, and I did mean to remove that delay there, but that's okay. So now you can see that our dragon, he's smaller than that rock. He's coming up to basically, I'm trying to point at the screen and realizing you guys can't see it and I don't have my mouse cursor anymore. But you can see where his face is aligning with you know, the bottom bump or the bottom of the bump on that rock there. So now we're gonna munch on our woo, and we just grew. And I've immediately lost control because I forgot to enable player input afterwards. But you can see that our dragon is growing. So if we go back into, even if you're in our dragon food, you can just double click on that node and it'll take you back to where it exists in the game. So we forgot to enable player controls after the growth happens. So then we want to drag out from our finished and type in enable input. In fact, it's not enable input, it's enable player controls. Reason being is even though we're just enabling the input here, you might actually adjust this code in the future. So you don't want to enable input directly because you want to make sure that you're calling this specific function. So compile and save, hit play, break out of our shell again, and go pick up our watermelon. And now we're a behemoth. We're growing in size. So let's throw a couple of more watermelons in the world and see how much fun this can be. So we're going to drag that out, put it over here, throw it up in the air, and drag this out, put it over there, throw it up in the air, hit end, Yeah, we'll drag out a couple of more just because I think it's funny. And oh, and this is actually, now this is something that's going to be interesting. As our dragon grows, he's going to have to move fewer and fewer steps before he reaches the trigger of the next watermelon. So if you put these too close to each other, what's going to happen is if you put one here and one there, when he eats this one, he's not going to be colliding with this watermelon. But as soon as he grows to a large enough size, he's going to automatically rotate and immediately eat the next one, which could be funny. So I'll show you that anyways. But it's something to keep in mind is you want to, when you're coding things this way, you want to keep your code in mind and space these out appropriately. And that's underground, so throw it up in the air, hit end, and then hit play. So we got our baby dragon spawning from the egg. He sees the watermelon. Yum, yum. Boom. Gets really big. Runs to the next watermelon. Yum, yum. Gets even bigger. Well, and this is something else to keep in mind. Now that he's so big, our target arm length hasn't changed. So that he's going to be obscuring our camera in a second. Grab the watermelon, yum. Yep. And he is now so large that we can barely see past the screen. And this is where I was saying, like, had I let's hit escape. Had I actually chosen these two first, you'd probably see that he'll eat one and then immediately eat the other if I put them too close to each other. But maybe at this size, it's not, yeah, it's not too bad. If we put these just a little bit closer together, and we do it from the exact wrong angle, you'll see, whack. I didn't mean to grab that one yet. I was trying to grab this one. But anyways, you guys get the point. Okay, so a couple of adjustments we need to make. So when our dragon grows, we got a couple of things to factor in. So firstly, our camera boom. So the target arm length needs to adjust. So probably what we're going to have to do is, again, just guesswork in the beginning, where we're going to have to multiply the length of the target arm length. Now, since currently we're just doubling the size of the capsule component, then we could also just double the size of the target arm length. So that's an easy one to do. So we're going to take our growth rate. We're going to drag off of our camera boom and get target arm length. We're going to take our target arm length and shift 8 to get a multiply, float by a float. And we're going to set this as our new target arm length. So we can run that. Let's see. Do we want to just run that off of finish? Yeah, I mean, sometimes I like to be too clean with my code, and I'll put in another custom event. Whoops, did not mean to do. Put a custom event here and call this adjust target arm length. Plug that in there. And then I still keep it within the bounds of the grow player, but keeping it clean here, now I can run possibly even in between here. So in between finished, just target arm length, and then enable player controls. And then the other thing is we want to adjust our movement speed as well. And again, because we're just doing we're doing it so he's growing double, we can probably double our movement speed and keep it scaled relative to the size of the character. So walk speed is 600. So we're going to say get walk speed. So we're going to get our max walk speed. We're going to multiply our max walk speed by another float, which is our growth rate. Whoops. And my dog is snoring on the floor beside me. It's really cute. Kind of like whining in his sleep. And sorry, just give me a second here, guys. Yep. And yeah, so essentially we're doing the same thing here with our walk speed. So probably drag this over here, create another custom event, and call this adjust max walk speed. And then drag out from here, set max walk speed. Oh, that's something else we actually probably would want to do on the fly as well, is adjust the set max walk step height. That's what we would probably want to do as well, because a 300-foot character not being able to step higher than 16 units or 48 units or whatever the default value is seems a little strange too. So if we look at our character movement, our max step height is 45, so 45 centimeters. If a 300-foot tall character can't have an increased max step height, then kind of useless. So you'd want to make sure that you're going through and adjusting all of these. So again, here we can drag off character movement, and we can go get step height. We can probably do both of these at one time. So I'm just gonna, actually, I'm gonna grab both of these, duplicate that with Control W, plug it in there, set this as our max step height, and let's do this a little bit cleaner too. So if I delete that, double click in there, drag out a line, and drop a new one down. This makes it a little easier to read when there's less noodles flowing all over the place, and I can double click in here and plug that one in there as well. Just rerouting our wires. And so now this one could be adjust max walk speed and step height. There is no downside other than the space that it takes up in width to making your function names really, really long, because it really makes it easy to read. What the hell is this doing? Well, we're adjusting the max walk speed and step height. And you can see, hey, yep, that is exactly what we're doing. The other thing you can do is, along with comments, you can left click on your custom event, and you'll see this little ellipses show up here. If you click on that and give it a name, so that gives it a little tooltip there. But when you zoom out, you can't see it. So if you hit this pin, now when you zoom out, you can actually see it from far away. So it just makes it easier to find your nodes. But the player grow is encompassing all of this. That's what you use comment boxes for. So it's up to you whether or not you maybe later on in your code, you might want to change this. And so rather than finding, if we turn that pin off, rather than finding player grow and then going, oh crap, where the hell did I put my adjusting the step height? If you put in these little pin bubbles, it makes it easier to find your code later on when you're looking at it 6 months from now. So Probably we want to throw that in here as well. So adjust walk speed and step height. And I'm trying to think of what else we needed to adjust. Probably you would want to adjust your jump height as well. So if we look back here, our jump Z velocity, 600. Now, probably that's the velocity at which you're jumping. I'm not 100% certain if that would need to increase as much as you get larger. So let's test that out. So now we'll see that as we grow, our movement speed will increase. And I never really showcased the movement speed. I was focused on the adjust the target arm length. So let's bypass this for a second. We're not going to be adjusting the walk speed. We will just adjust our target arm length and we'll hit play. And before I do that, now that I'm thinking of it, let's go back into our baby dragon character here. Nope, we're going to be needing to go into our eggshell. So we've got a delay in here before we're possessing that character. So delay before control is 3 seconds. So I'm going to turn that down into 0.5. And that should probably make it so we're not sitting in our eggshell for quite so long. Because it does take a while to play that hatching animation. Yum yum, boom. We're a lot bigger, and now you notice that we just snapped to a new value. But this is messing up our IK, it seems. So that's something to keep in mind when you're, wow, this looks fantastic. So when you're playing with IK, looks like it caught up though. No, something got messed up. So when we're scaling up our character and we're using the IK system, oh wow, that's fantastic. Probably it has problems of its own that you have to go through and adjust. So let's go back into our NMBP. We're just going to bypass the IK system for a second here as well. See if that solves our problem. It's the joy of debugging game design ideas. So yum, and then boom, our camera jumps back. No, he's still getting really messed up. I wonder why that's the case. We'll have to fix that. Yum. It's even bigger. So now you'll see that I've disabled the adjusting the movement speed. So now it feels like our big dude is taking forever to walk anywhere. Wahaha. Our dragon is getting gigantic. As big as mountains. Can't even see the little watermelons he's eating anymore. Whoa. Dang, this is getting buggy. Oh, I love it. What the hell is going on? Every time we're growing, it looks like he's somehow like getting pushed out of his capsule component. Yeah, I don't really understand what's going on, but you see how relative to the size of our character, he is walking really slowly now. But we are freaking gigantic too. We're the size of mountains. Because we're doubling in size with every watermelon we eat, which is going up exponentially. This is fantastic, though. I love this. Yeah, it's like breakdancing dragon. Okay. So, one of the things we can do to try and debug that, and go back into our baby dragon, we can take our capsule component, turn off the hidden in-game. And then when we hit play, we'll actually see our capsule component. Okay, so the problem is our capsule component is a sphere, so you can't tell if the rotation is getting thrown off or what. But anyways, doubling in size, that's fine. Getting bigger and bigger. Even bigger. Yeah, I have no idea. I think what's happening is it's adding a rotation to our capsule component every time we eat it. So we're just spinning our character in the world, which is weird because I thought, again, I limited that to the z-axis. So what I'm going to do here is, because our capsule capsule component is a sphere, I'm going to turn back on that hidden in game, but I'm going to add an arrow component. And up arrow. And I'm just going to place that kind of at the top of our collision here. And I'll rotate it 90 degrees so it's pointing up. And we're going to turn off hidden in game. File and save. Now we can take a look and get an idea that I think what's happening is we're rotating this way. So there's our up arrow as we eat and grow in size. Yeah, see, now our up arrow is angled slightly. So we're rotating our character forward every time we eat a watermelon. And that's our glitch with our player look at, I think. Why did he get to the point of like walking on his nose? Because here he's essentially walking on his nose. I mean, we are tilted quite a lot. Now let's see if we can get that one more watermelon. Grow monstrously huge. Damn, I don't even think we can collide with it anymore. Oh, there he goes. No, oh, I thought he was eating it. He was just falling. I don't even think we can collide with it anymore. It's like, it's in between the mountain and the rock. And our capsule collision isn't even intersecting with the trigger anymore because we're so huge. That's hilarious. All right. So going back into our baby dragon, our event graph here, player look at target. What the hell is going wrong? So we are event graph. So we're getting the control rotation of our player controller. That's fine. We're getting the camera rotation. That's fine. We're getting the camera location. That's fine. And we're getting the capsule rotation. So this is where we only want to get for capsule rotation. We only want to get the Z value, the yaw. So split, struck, pin, punch in the yaw, leave everything else at 0. But we don't really want to leave it at 0. We want to leave it where it is. Now, we're just getting the world rotation, so this actually probably shouldn't matter. Recombine. That can still actually be set as whatever its value is. So capsule rotation, where are we? We're not even using the capsule rotation, actually. We're setting it. Probably we were previously using it. So we're getting the camera rotation and the player rotation. So we're looping from whatever the player rotation value is to the camera rotation value. And we're blending the camera rotation value from where it is to the look at target. So the location of the look at target, which becomes a rotation. So that's fine. So we're blending from our camera rotation to our look at targets rotation. And we're lerping that into our set control rotation. So this is the problem here. I'm actually getting the set control rotation. I don't want to be doing that. I want to get my capsule rotation for setting the world rotation of the capsule. So I want to get my capsule rotation here. And I want to do another lerp from, let's see, let's get rid of that. So we're going to lerp. Let's just duplicate that. We're going to lerp from our capsule rotation to our target rotation with the alpha shortest path. And we're going to split that struct pin and plug that into Z. And I think this might fix it, because this is just setting up where we're rotating our controller, so where the camera is facing. So that can all stay the way it is, because the camera can rotate this way as well if we want it to. But the capsule, we're getting our new rotation, which is the math behind the find look at rotation, so where our target is. We're going to basically rotate our capsule to face it, but we want that to be limited to the z-axis. And if I've got that correct, this axis here, which is our z, yeah. So we're going to do that, compile and save. That should fix our weird rotation glitch. Yum, grow up in size, still pointing vertical. There we go. Yum, grow in size, arrow is still pointing up. Yum, arrow is still pointing up. Hooray! So that was what was causing that funkiness. Yum, get really big. That is what was causing the funkiness. Oh man, that watermelon is so small now you can barely see it. If I hit F8 and jump out of my dragon, there's our watermelon. That's one huge baby. Get in my belly. Yeah. All right. So let's grow even bigger. Boom. Gigantic dragon. But as you see, he's walking, but we ain't moving anywhere. So that's where we wanted to scale up our movement speed here. So if we adjust the walk speed and step height, that means he'll actually be able to step over the mountains, and probably we can turn back on our IK. So plug that in there and plug that in there, because we've fixed the issue with spinning our sphere, not spinning our spear. All right, hit play. Try one more time. There we go. Munch, munch. He grows in size in his feet. He was still kind of floating there for a bit. What's going on with that? That doesn't look like it's an issue with our IK. It's probably an issue with our capsule. So because our capsule is a sphere, and that sphere is getting to be a big size, and that, imagine that the sphere is going into a dip, but the sphere is actually bridging the gap in the dip. So therefore our dragon actually can't move through the dip because the capsule component is bridging it. So what used to be a wide gap is now becoming a tiny little gap compared to our dragon size. So our scale factor is going up too quickly. But then again, now I say that, and yet, yeah, he's He's fine here. So why is he floating in the air there? That is very strange. That's something to do with the IK, I'm pretty sure. So IK really doesn't like it, I think, when you just randomly adjust the scale of your character on the fly. It probably confuses it. So that is very odd. And I would imagine, I'm assuming it's the IK. Let's take that out again. Compile and save. Go back to that same point there. And see if it's continues to be an issue. Yeah. So it's our IK system. So probably I'd have to look into the documentation of Power IK more to see if it's possible to adjust the values. Again, like I said, because our character is getting to be twice the size, the numbers don't apply so much anymore. But it could be something to do with the rate, like the tick rate of the Power IK system. But yeah, essentially now as we get huge, we'll actually still be able to walk properly in the world relative to our character size. There we go. So we still feel like he's moving at a speed correct to the scale of his size, right? And we can still step up on top of the mountains because our step height has been adjusted properly. Now, granted, the mountains are a slope. Your step height is traditionally for stairs, but it also is going to apply to a slope. If your step height is 45 and the slope is massive, you won't be able to even start to climb up the slope. Is that our last watermelon down there? I think it was, but we're too big now to get it. Oh, that's our egg. That's where we hatched from. That's our home. All right, guys. So yeah, as goofy as this is, I think we're gonna leave it here. And yeah, our Z velocity, it doesn't seem to need to scale because our dragon can still jump with that same Z velocity for our jump speed. But granted, you might want to increase it a little bit. But guys, I'm going to call it a day. Thanks so much for watching. It's been fun. Hopefully, Charlie likes the results of this tutorial series that he requested. We have officially hatched our dragon from an egg and also allowed him to eat food and grow into monstrous proportions. So yeah, thanks so much guys for tuning in. See you this time next Sunday, 4 p.m. Who knows where we'll go from there. Bye for now.